Welcome to the core mechanics of deep learning. Today, we dissect the two bookends of every neural network, the input layer and the output layer. While often overlooked for the complex hidden layers in between, these two layers define the network's scope, acting as the crucial gateway for data flow and final decision-making. The input layer is the entry point, the nervous system's sensory organ. Its singular purpose is to receive and distribute raw data to the rest of the network. Imagine feeding a network an image. The input layer doesn't process the picture. It simply organizes the pixel values. If the image is 784 pixels, this layer must have exactly 784 neurons. Each neuron corresponds directly to a single feature, and unlike every other layer, the input layer performs no computation, no weighted summing, and no application of an activation function. It is a simple but structurally essential conduit. The output layer is the terminus, the network's voice. After the data has been transformed and analyzed through the hidden layers, the output layer is responsible for translating the final internal state into a meaningful result. Its structure is dictated entirely by the task. For a classification problem, the number of output neurons corresponds to the number of classes. If the network must decide between 10 types of objects, the output layer will have 10 neurons. Here, the activation function, like softmax, is critical, converting the final scores into probabilities, giving us the network's ultimate prediction or action. So, how do they compare? Both are boundary layers, fixed in size by the problem at hand. However, their functions are inversions of each other. The input layer is defined by the dimension of the data, acting as a data translator from the real world into the mathematical space of the network. The output layer is defined by the dimension of the target, acting as a result translator from the network's math back into real-world meaning. The input layer is passively receiving. The output layer is actively deciding. Understanding their distinct and complementary roles is key to effectively designing any deep learning system.